Okay, now we're in the graphing part of this lesson. And what I wanted to do was I wanted to start by graphing an exponential function and then take a look at its inverse, the same function with the same base as the log, and then talk a little bit about domain restrictions. Okay, so for your exponential function, fx equals 2 to the x, always put in 0 and 1. So f of 0 equals 2 to the 0, which is 1. F of 1 equals 2 to the 1, which is 2. So we get these 2 points, and we've got a horizontal asymptote going off to the left, exponential growth going off to the right, or going to a positive infinity off to the right. Now, when we graph the inverse, we're just going to graph those 2 points backwards. So I'm going to graph a point at 1, 0, and another point at 2, 1. And what this is it's really, so our our horizontal asymptote in the original function, in the exponential function, turns into a vertical asymptote in the logarithmic function. Which means we've got not range restrictions, but domain restrictions on logarithms. So for any logarithm that doesn't have a left-right transformation, x has to be greater than or equal to 0. If the graph moves left or right, then our vertical asymptote moves left or right that many places, and so does our domain restriction. So state domain and range for f to the minus 1, domain, x has to be, sorry, I'm mixing up my notations here, x has to be greater than or greater than 0. And the range, there are no restrictions, so it's all real. In XYZ, they only ask you about the domain of logarithms. Okay, so we're going to crunch through a few of these. Graph each function, state its domain, range, and vertical asymptote. So what you need to know about a log base that is between 0 and 1, like on problem A, is it's going to invert our logarithmic graph. So let's take a look at a couple of points. What power do we raise 3 to get 1? What power do we raise 1/3 to get 1? That's going to be 0. Okay, so we've got a single point at x equals 1, y equals 0. And let's think about 1/3. If I have, and it's easier to think about them as exponents, if I have 1/3 to the negative 2, that's going to be 3 squared, which is 9. Okay, so what power do I raise 1/3 to get 9? That's going to be negative 2. So that gives me another point at 9, negative 2. So let's graph those 2 points. X equals 0, x equals 1, y equals 0, and also x equals 9, y equals negative 2. So like I said, when our base is between 0 and 1, it flips our logarithmic. It's a looks like a reflection across the x-axis. If you compare it to a base like in example 5, where the base is greater than 1. Okay, so domain, range, and vertical asymptote. The domain, again, x has to be greater than 0. The range is all real, and my vertical asymptote is at x equals 0. So wherever your domain moves to, that's where your vertical asymptote moves to as well. Okay, if we look at common log of x minus 5, hey, by the way, the base of these logs don't really matter other than trying to find points. So this is common log of x minus 5. So this is a logarithmic function that's translated right 5. And we don't really have to know a whole lot more about that. My base is greater than 0. If I throw in, let's say I throw in a 6, I'm going to get log base 10. What power do we raise 10 to? To get, well, I throw in a 6. I'm going to subtract 5. I get a 1. What power do we raise 10 to get 1? Well, that's always a 0, so we've got a point at 10, 0. 10, 0. And our basic log function is going to look something like that. Our domain, x has to be greater than 5. Our range is, again, all real. And then the vertical asymptote moves to x equals 5. They're interested that we can basically state the domain, the range, and the vertical asymptote. And by the way, the range is always going to be all real, so I'm going to skip that. State the domain. And by the way, the base of our log does not matter for these things. State the domain. Well, this is going to be left 3. So my domain is going to be x has to be greater than negative 3. And my vertical asymptote is x equals negative 3. Here we want to see what's going on because we've got a lot here. But remember, inside our logarithm always has to be greater than 0. So negative 5x minus 6 needs to be greater than 0. And we're just going to use this inequality to solve it. I'm going to add 6 to both sides. Now, when I'm multiplying divided by negative 5, I must remember to change the direction of my inequality, or I'm going to get this wrong. X is less than negative 6/5. All right, so that means my whole graph is going to go to the left of negative 6/5. So that for my domain, that means x has to be less than negative 6/5. And for my vertical asymptote, x is equal to negative 6/5. Okay, this one, you know, the only thing that matters here is this left-right translation. This is going to be a reflection, all right? So it's going to make it look like it has a log base between 0 and 1. Not important for what they're asking, the domain and the vertical asymptote. So this moves right 1. That means my domain, x has to be greater than 1. And my vertical asymptote, x equals 1. All right, done with this video.